Good morning. It's a lovely sunny Wednesday, and here I have it's a DVD power supply from a DVD player, and it's faulty. It's broken. It doesn't work. Now I don't want a DVD player, but I thought it would be a very good learning experience to try and get this fixed, work out what's wrong with it, how it works, what's wrong with it, why it doesn't work, get some parts replaced and get it working. And it will be a good introduction to learning about switch mode power supplies. Now we always get told not to mess around with power supplies, so I was a bit reluctant at first, but we're going to give it a go. So the first option, find out how it works and what it does. So initially, beginners knowledge coming up. You have 230 volts come through here. It then goes to a switch and a fuse, which is burnt out. 230 volts AC then goes through the capacitor, through a filter. Now the filter's there, I believe, to stop noise, electrical noise, from the power supply going back out into the mains. So you've got 230 volts AC, because we're in the UK. It then passes through these 4 diodes, which form a bridge rectifier. And the bridge rectifier cuts the bottom of the AC wave and gives you an output of DC. Now apparently when it does this, it takes the 230 volts AC and it multiplies it by around 1.4, so you end up with DC, approximately 320 volts DC comes out of these and fills this capacitor, which is why presumably they tell you not to mess around with them, because this capacitor is potentially full of 320 volts DC. From the capacitor it goes to this component here, which I've actually taken out, the MOSFET. The MOSFET switches on and off and loads up this transformer on the other side, which lowers the current and the voltage down to something more manageable. Now from here, this power supply outputs 12 volts and 5 volts. Now I'm assuming, not known for sure, that this inductor handles the 12 volts and this inductor steps it down to the 5 volts. See that little coil? I'm assuming that's how that works. Now if I look at the board, I've got some scorch marks around the shield, the heat shield, on where the MOSFET was, which is why I've taken that out. And I've got some scorch marks here on the board, which was this component. And this is it's an optocoupler. It's an 817 optocoupler. So I've took that out as well because it's got some visual burn marks on the board. So this morning I'm going to test this optocoupler, find out what it is, what it does, what it is, how it works, and let's see if we can. I don't want to just replace it. I want to know what it does and I want to learn from it. So I'll put that to one side. So the optocoupler, as I found out, because I've been doing my research, is inside of here there's a small LED and there's a transistor, and when you pass a current through the LED it lights up and the phototransistor signals a phototransistor, and the phototransistor closes and allows current to pass through the pins on the other side between the emitter and the collector. And this one is possibly faulty. So I'm going to test that with my breadboard. So I've got two power supplies on my breadboard. I've got a 3.3 volt lithium ion battery, and I've got a 9 volt battery for this side of the breadboard. So what we're going to do is we're going to make sure these pins are set up correctly. I'm going to put that in there. Yeah, now straight away, because I've got my breadboard, I haven't even got my breadboard switched on. Straight away, the pins 3 and 4 for the emitter and the collector are shorted closed, and it's allowing current to pass through the internal phototransistor to light up my LED. So I know that that's faulty, that's not right. It should wait for a signal from this side before it closes. So we're going to switch, we'll pull that out, and we're going to swap this faulty one over for a good one. Now I've actually gotten this from an old power supply board. There's one there on this power supply board. This is an old board which I've used for spares. But I've actually gotten this one from another board. So we're going to test this one. We're going to connect up the power for the LED. Now this time the LED hasn't came on because it's waiting for a signal from the other side, from the LED inside of the photocoupler. So we'll put power to the board. So I've got power to the board, I've got power to here. When I flick this switch, you can see, so what's happening here is when I press the switch, I'm putting power through this side of the board, the little LED's lighting up, and it's triggering the phototransistor inside, and it's allowing current to pass through from the collector to the emitter and lighten up this LED. And I'll be honest, I'm a bit over the moon with that. I've learned something new. I didn't know what an optocoupler was, so I'm over the moon that I've been able to find a replacement. I've been able to prove that this one is faulty, and I've been able to prove that this replacement is working as it should with my little breadboard experiment. So that one can go back onto the board, and the next thing I'm going to look at is I'm going to order some new MOSFETs, and we'll get the new, we'll test the new MOSFETs against the old MOSFETs, and we'll get these two pieces back in. And following that, I may have to look at this resistor. I'll have to replace the fuse because the fuse is gone, and I've got a resistor here with a small chip out the paint, so I'll have to take that off the board next time, and we'll look at that. We'll look at that too. So hopefully by the end of this series, I'm going to have a few videos on how to fault find the different components that have gone faulty on this board, and by the end of it I'll have a much better understanding of how a switch mode power supply works. Thanks for watching, and I will see you in the next one.